Imagine this: somewhere in the world, and you're sitting in the midst of nature, and you're enjoying a cool breeze, and you're listening to a playlist on differentiation. This is what I hope somebody is doing right now. Okay, so we are going through our AS and A2 revision series, and now we are doing a very interesting topic, and it's going to be differentiation. Now, first, before we get into the work, I'm going to do it very fast, and I'm going to be quickly summarizing the things for you. But before that, I'm going to just show you my contact details in case you want me to tutor you online. Maths and sciences, okay, anything that is math and sciences. So whether it's physics, whether it's computer science, whether it's chemistry, I can help you through all that, and you can get help. So these are my details. You can take these numbers, text me on WhatsApp, or get your parents to text me on WhatsApp, and they can organize so that I tutor you online, and then I get you over the line, okay? Because I want everybody who is listening or watching this to get cracking grades. You have to get cracking grades. How good is that? All right, so now let's go through. We are going through the topic of differentiation now, and I'm going to, in this video, this is not for an AS student, this is not for an A2 student, this is for all A-level students. Not just AS, not just A2, but every A-level student. This is a good video for you, because in here, I'm going to show you the structure of this whole animal. Because if you look at your thing, for you to say you are done with A-level mathematics, you are going to write paper 1, pure mathematics 1, and you're going to write pure mathematics 3, okay? Then of course you're going to write the other two other papers, but for pure mathematics you're going to write 1 and 3. And if you look at it, pure 1 has 8 topics, pure 3 has 9 topics, and it looks like you have 17 topics, but in reality you actually don't have 17, okay? It's less than that, because there are topics that are just a continuation, and differentiation is one of those topics. We have trigonometry, another, we have integration is another, and I can show you all other things like algebra, but they kind of get different. But then this is just a continuation. So, and there is the same thing here, and that is the same thing here. Now, when we talk about differentiation, this is one of the easiest topics, and I want you to know that it is unacceptable for you not to crack this in the exam. There is no way this topic should hit you. It is not acceptable. You should, destroy it, because it's just that simple. So you say to me, is it? Yeah, it is. Now, let me give you a picture of the whole of this thing, of the whole of differentiation, okay? And I'm going to show you what comes for AS and then what comes for A2. So now what you must know is that we are doing differentiation. For you to be done with differentiation, let's put the things, and then I'm going to show you the parts that will be AS and the parts that will be A2. But in reality, it's one thing. It's differentiation. Okay, differentiation 1 is the one from pure 1, and we'll call the one that is you're going to write in pure mathematics 3, we'll call it differentiation 2. Okay, in some books, you find it being called further differentiation. Same thing, no difference at all. So what is this? Now, for you to be good at this, what you're going to do is, I don't know, what is this? I don't know why this thing is in my way. I should get it up. Okay, you should be good at, number 1, knowing the 5 type of functions. So differentiation is hanging here. 1, the 5 types of functions. And then when you do this, then the next thing is going to be the 4 rules. So differentiation is hanging on 1, the 5 types of functions. These are the things that we should be able to differentiate, or we should know how to differentiate. Then we should be able to use the 4 rules of differentiation. So this is what we'll be having in differentiation, okay? This is what we'll be having. And of course, you're going to put 2 more things, okay, after that, and that is going to be parametric, and implicit functions, okay? Parametric and implicit functions, or implicit equations, same thing. So we can put the 2 more functions, which is going to be parametric and implicit, but they are standalones. We won't put them in these 5 main types of functions, okay? When we do this, we would be done with differentiation, and we would now just be looking at application. So if you do this, this is going to be your differentiation. And when you're done, what do you do next? You are going to do application. Okay, so 1 is differentiation itself. Okay, or let's say under differentiation, the 1 is going to be this. Then this is going to be part 1, the whole of this thing, which I'm going to put here. This whole thing is going to be part 1. Let's put it. This is going to be part 1. Then next, you are going to do part 2, which is going to be application of differentiation. And you're done. You're going to do this. What is it? Lipid. What is lipid? These are the 5 types of functions, and you must be able to differentiate each of the 5 type of functions. So that's 1. For us to say you are done with this whole thing. So listen to this, my friends. Look, I'm going to prove it with the syllabus. I'm going to show you, because the syllabus will write it in a fancy way. It'll write the same thing I'm going to tell you in a more fancy way, but right now I'm breaking it down to put it in your head. For us to say, I don't care whether you are doing AS or A2 or both. For us to say you have, because we are going to split it, don't worry. We'll show you the part that comes for AS and the part that comes for A2. And you see how simple this whole thing is. For us to say you are done with differentiation, what must you be able to do? That's the biggest question. What is this whole thing? What is it all about? When do I say I'm done? Well, for us to say you are done, you got to be able to differentiate all of these 5 types of functions. Okay? You got to be able to differentiate all of these 5 types of functions, and then you have to be able to use the 4 rules, because in the 4 rules, what will be happening is we will be combining functions in different ways. The only one where we don't combine functions in different ways is the first rule, and I'm going to show you. So put this in your mind first, because I cannot say everything in the first because it's going to be too long. But I'm going to list for you the 4 rules in the next one, and I'm going to show you what the 5 types of functions are, and then whatever. But for us to say you are done with differentiation, then what must you be able to do? Number 1, you must know how to differentiate the 5 types of functions. Number 2, you must know the 4 rules, which is the power rule, the product rule, the quotient rule, and the chain rule. You must be good at all 4. Okay, this is for you to be good at the whole differentiation, both AS and A2 together. So you need to be 1, know how to differentiate all 5 of these types of functions. 2, know how to use the 4 rules and what situations you use them in. Then 3, you should know how to differentiate what we call parametric equations and what we call implicit equations. And you're going to see, for implicit equations, these are just equations where you cannot make y the subject. Okay, if you can make y the subject, then it's called an explicit equation. We don't care about that one. In this one, for implicit, you may find a situation where you can't make y the subject, but you should differentiate. So you need to know how you do it. And then for parametric, it is when you have parametric equations are equations that have 2 equations in one. So it's a function that has 2 equations or more describing the same thing. And you're going to see those. And you need to know how you can then go on to, it's very similar to the chain rule, okay? You should see how you then go on to find the derivative which you actually want. Because your function will be in terms of other things. Let's say you want to find dy dx, but then you have x as a function of t, and then you have y as a function of t, whatever, and you want to actually find dy dx. So you have y as a function of t, x as a function of t, but you want to find dy dx. So how would you now change y as a function of t and x as a function of t? How do you now combine both to find dy dx? How y affects x? That is those are what we'll be calling parametric. And then you now come to application. In application, you're going to so first is the differentiation itself. Okay, differentiation is differentiation and application. So first is the differentiation itself. And for P3 actually, there is no application. There is just a little bit of application, which is just one line I'm going to show you. You're just going to apply it a bit. But application, mostly you are introduced to it and for paper 1 and in paper 1. So what is it going to be? In application, that is where you're going to apply now the things you know to a question that wants you to find the, say, equation of a tangent. Okay, so equation of a tangent. Okay, and then you should be able to find equation of using differentiation. Okay, equation of a normal line. Then you should be able to find the stationary points. You should be able to find stationary points. Then you should be able to find not only that. Okay, we have the equation of a tangent, equation of stationary points, and you must also be able to find increasing and decreasing functions like intervals. We'll talk about it. increasing and decreasing functions. These are just some things that you can use. All these things you can find, and you should find on stationary points. You should find them, and you should be also able to find their nature, because you are going to learn about what we call the second derivative and the third derivative. You'll be just using the same things that we have talked about, okay? Either the knowledge of how to differentiate the 5 functions or the 4 rules. You'll be using one of them to find the second derivative, and the third you just differentiate again. Okay, so if you know how to differentiate, you can just differentiate once and then differentiate twice. It doesn't change anything. And you're going to see how we use the second derivative to find the nature of the stationary point. Stationary point is also called the turning point. So we'll find out when a curve turns like this. We'll see when it turns at a high point like this, we'll call this a maximum turning point. And then when it's like this, we'll call it a minimum. You see how we'll find it. And then finally, you see how we apply it to rate of change. Okay, rate of change and connected rate of change. This is going to be the last thing. Okay, and connected rate of change, and would be done. These are some applications. Okay, if I've left out any application, you can see. But this is the whole of differentiation. Please remember it. This is important. What is differentiation? If you want to be good at it, then the things you gotta know is how do you differentiate the 5 types of functions, and how do you use the 4 rules of differentiation, which is the power rule, the product rule, the chain rule, and the quotient rule. Then it is going to be parametric and implicit, and you are done. This is the whole thing. Then you go to application, which is now using that knowledge to then find different things, and you must know how do I use the derivative to find equation of a normal. How do I use the derivative to find equation of a tangent line? How do I use the derivative to find the turning point, the stationary point, and its nature? How do I use the derivatives to find which interval a function is increasing or decreasing in? How do I use a derivative to find the rate of change? So this is now just application, and you will be done. How simple is this? Maths, we are coming for you. I tell you, we are going for that guy. And make sure you have this whole picture in your mind, and then the whole thing becomes easy, because when you're doing it, one of the most important things you need to be able to be good at is to know what you are doing. You don't want to just learn and learn and learn and learn, and you don't see the whole picture. You got to see what you're doing, where it starts, where it ends, and this is what I'm telling you. This is the whole picture, and you would be done. Okay? You got to know this. Now let's go ahead and let's do the next thing. Goodbye.